Okay, the very first thing that we need to learn about the grouped frequency distribution is that these distributions are used mainly when the range of the data is large. So if you look at, okay, the other thing that we need to learn about is the lower and upper class limits. Okay, your smallest possible data value is going to be your lower class limit, and then the upper class limit will be the largest within that class. The class boundaries, those are what's going to separate the class, and that's always going to go out one more decimal place further than what's given. So for example, if we had 11 to 12, let's say that was our class, we would say that the boundaries would be 10.5, again I'm going out one more decimal place than what's given, to 12.5. Okay, so it's going to be, the boundaries are going to be a little bit before and a little bit after. Okay, so to find your class boundary, here's another way you can average the upper class limit of one class and the lower class limit of the next class. That to me is a little bit more complicated than just thinking a little bit before, a little bit after, and again take it out one decimal place. Okay, this is very important when you create your group frequency distribution. Your class width, that is calculated by subtracting either your lower class limits or your upper class limits. Another way to look at it is you could subtract the upper and lower class boundaries, but again, not the limits. And then I'll go into an example with that later on. The class midpoint, that's calculated by averaging your upper and lower class limits. So it's exactly the midpoint in between those class limits. So for example, if we had the class 11 to 12, your class midpoint would be 11.5. Simply add the two lower class limits together, divide by 2. It's that easy. Okay, so there's some rules when we create our grouped frequency distribution, and that is there needs to be between 5 and 20 classes. So you don't really want to go under 5 and you really don't want to go over 20. It just becomes way too cumbersome and just too much information for somebody to digest. If we're looking at, 1, 2, 3 classes, honestly, a group frequency distribution should never have been created. You should have just displayed your data. The other thing is the class width, it should be an odd number, but I'm not very strict about that, and the majority of people are not. Everything else, very, very important. The classes must be mutually exclusive, or in other words, they need to be completely separate. For example, you cannot say 11 to 12 and then start off your next class with 12. Because where would you put the number 12? Would it go in this area or this class? So you cannot have any overlapping whatsoever. That's what mutually exclusive is. They need to be completely separate. They must be continuous. Okay, so it needs to go from anywhere from 11 to 12. That contains everything in 11 and 12. It must be exhaustive, so it needs to stop at a certain point. You cannot say anything greater than 105, for example. And then this is very, very important. Classes must be equal in width, unless we're talking about an open-ended distribution. But we're not really going to get too much into that. You don't see that too often. Okay, so the very first example we are going to do is construct a group frequency distribution for temperatures for the 50 states. Okay, these are the record high temperatures for each one of these states. and we are going to create a group frequency distribution, and they're telling us that we're going to do this with 7 classes. Okay, so it gives us the 7 classes, and the very first thing we want to do is figure out our class width. Okay, so it already told us the number of classes. Yeah, we have 7 classes. But now we have to figure out the class width. So what we do is we take the highest number. Now we have to determine what the width is. So the width is going to tell us how we're going to arrange our group classes. What we have to do is we have to take the highest number that was listed. In this case, it was 134. And the lowest temperature that was listed was 100. So of course, we're going to end up getting 34. That's our range. So we take our highest minus our lowest, and then what we do is we divide by the number of classes. So it already told us in the directions that 7 classes was going to be the frequency distribution we were creating. So I'm just going to take the 34 divided by the 7, and I get an answer of, let's see, it's not going to be exactly 5, but we get 4.857. This is really, really important, guys. We're always going to round up. So even if I got 4.1, I'm still going to round that up. All right, so now, like I said, our class width is 5. Now, if you recall, class width goes from lower class limit to lower class limit. You want to start with the lowest data value. For example, 100 was our lowest data value. And I just keep on adding 5, as you can see. Now, if you remember from our rules, these must be equal in width. So all I'm going to do is add 5, add 5, add 5, as you can see. Okay? And then if you look at our upper class limit, remember, it needs to be mutually exclusive. So if we started this next one at 105 here, this next class, this one only needs to go to 104. If we started this one at 110 here, this one needs to end at 109, and so forth. You want to make sure that all of your data values are included here. As you recall, we had our highest data value was 134, so we're in good shape. It's going to fit within our group frequency distribution. If it does not, you did something wrong with either determining the class width or setting up your group classes. So you want to go back and check that. Okay, so now what we did was we went through and we filled in the class boundaries for each one. Like I said, this should be going out one more decimal place than with the class limits. So we want to go a little bit before and a little bit after. So a little bit before 100 would be 99.5. A little bit after 104 would be 104.5. Now these here should overlap a little bit. As you can see, 104.5, we start the next one off at 104.5. Okay? So what we're ensuring is that our data is continuous, or our classes, are continuous. They are going to fall within our boundaries here, all of the data values. And then what we could do is we could go through and we could do a tally. We can go through and say, okay, the very first temperature was 112, so 112 is going to fall right in here. The next one was 110, it's going to fall right in here. The next temperature is 107, that's going to fall in this class. The next temperature is 116, that would fall here. The next temperature is 120, that would fall right here. So you would go through and do this for each one of your temperatures. Like I said, there's a whole lot of temperatures there. There's 50 temperatures. So that's why we're even creating the group frequency distribution, because there's so many data values. When you see that many data values, that means, not a whole lot to a whole lot of people because you need to organize it in some way. It needs to mean something. And then when you go to do your cumulative frequency, that means you just add it up as you go. So when all's said and done, your frequency for each class is as follows. So that means your cumulative frequency would just add up as we go. So far we have 2. And then within this class, we picked up 8 more. So now I have 10. Now I have 10, and I recently added 18 more, so I'd go with 28 here. 28 plus my 13, that's going to give me 41. 41 plus my 7, that's going to give me 48. And then, of course, 49, and then 50. Again, here's a much neater version of how we found that cumulative frequency.